So that science journalists can fulfill this very useful function in a wide open field of spotting connections, connecting dots that scientists who are immersed in their own discipline may not spot. She said, well, why don't you just get a culture medium of opposite chirality molecules, amino acids right-handed, sugars left-handed, and see if anything will grow in them. In other words, you have a bowl of soup and a bowl of anti-soup or mirror soup. You can buy this stuff commercially. So although life itself doesn't make the opposite sugars and amino acids, you can make them in the lab, and you can buy this stuff, and you can do this experiment. So you might expect life as we know it would find the anti-soup or the mirror soup indigestible and would not get on very well, but any microorganisms that were the mirror image, mirror life if you like, would gobble it up and thrive. And so you would soon separate known life from maybe a tiny, tiny component of mirror life, but it would eventually, by exponential growth, manifest itself in an obvious way. It's a really neat idea. And we persuaded the astrobiology center at the NASA Marshall Space Flight Center to do this experiment as a pilot experiment, and they got some very interesting results. I don't have time to go into that here. So it's one possible approach to a filter. Now let me just wrap this up by saying, well, supposing we do discover a candidate microorganism, a microbe somewhere, in somebody's lab they say, hey, this is really different. This is a microbe using a doublet genetic code instead of a triplet genetic code. This must be life 2.0. Well, then the arguments will begin, because could these two apparently different trees of life actually connect up lower down? In other words, might we have discovered not a completely new tree of life, but an exotic branch on the known tree of life, one that we've overlooked so far, exotica? Is that possible? How are we going to tell the difference? Let me give the example of the doublet code. I think personally the triplet code is so complicated it probably was not the original code that life on Earth used. I think it probably started out with a doublet code and maybe a suite of only 10 amino acids, and that later on it evolved a triplet code, more complicated, and then commandeered another 10 amino acids to give us the 20 we've got. But that doesn't mean that the original life using the doublet code is all gone. It may be, but it may be it's living on. If it's in conditions that haven't changed very much during the history of the Earth, maybe there are places on Earth where life using a doublet code still exists. Old-fashioned guys, living fossils, if you like, doing it the old-fashioned way. So we may discover a microorganism using a doublet code, but on closer investigation find it is in fact one of our ancestors, a living fossil.